Okay, so in today's class we'll be doing revision of vectors, of which we'll be solving the tutorial sheet for 2022-2023 intake. So this is a tutorial sheet that was prepared by the University of Zambia, specifically the School of Natural Sciences and under the Department of Physics. So we'll solve part of the questions. So this will be my part 1. So my part 2, I'm going to solve another set of questions for this same tutorial sheet. Part 3, I'm going to solve the tutorial sheet for physics 1100. I don't know if it's 1100 or 1000. And then we'll continue until we solve all the tutorial sheet. Then we'll focus on the exam past papers. So the reason we are solving this tutorial sheet is just for me to help you guys when you come here next year or any year, you'll be able to know that, okay, this is what I'm expected to know, or what I'm expected to focus on. Okay, so we'll quickly start. So that's just the same tutorial sheet, just for confirmation, in case you have come across such a document. So that's the document we are simply utilizing today. So I'll start with the first question. So the question is, what are the x component, and b, what are the y component of a vector in the xy plane if its direction is 250 degrees counterclockwise from the positive direction of the x-axis and its magnitude is 7.3 meters. So guys, feel free to ask questions and feel free to participate. So yeah, so I'll start my solutions. So I'll simply write their solutions. So solutions. So the first thing that you guys need to know is to understand the xy plane. So the xy plane is very important for you to understand before you do anything. Actually, the question has even told us to use the xy plane. So in this case, you are going to have the y-axis and also the x-axis. So this is the y-axis, and then this one is the x-axis. And then from the information that we have been given a vector. So this vector is 250 degrees. So if you look at 250 degrees, you need to understand that this is in the third quadrant. So the first quadrant will end up to 90 degrees. I'm sure you guys can remember from the lecture class. And then the second quadrant will end up to 180. So the second quadrant will be between 90 and 180. And then the third quadrant will be 180 and 270. And then the fourth quadrant will be 270 and 360. So according to the information we have been given, where the vector is 250 degrees, so in this case we need to understand that we are just dealing with a vector which is in the third quadrant. So this is the vector which is in the third quadrant, and this vector is having the direction which has been stated to be 250 degrees. So this is just simply 250 degrees from the positive x-axis. So the angle there is just simply 250 degrees in the third quadrant. So before you even look at what you have been told to solve, you can simply utilize the information from here. Remember, this is the resultant vector. So let's say this vector is vector A or anything. So you need to understand that this vector is simply A. Okay, let's say this resultant is vector A. So in such a case, you need to understand that for us to have this particular vector, it has two important components which we need to understand. So the first component is the x component, which is this one, So this is the x component, and you're going to name it as ax. And then the other vector, the other component of this particular vector, which you need to analyze or understand, is the y component of this vector, which is just simply ay. So you have two components of the vector. You have the ax component and the ay component. So when you talk of ax, this simply means that it's the x component we are dealing with, and when you talk of ay, we are simply talking about the y component of this particular vector. So remember, we have been given the direction, which is simply the angle, and that is 250 degrees. So this is it's more like the free body diagram, and this diagram will guide you on what to use and which one are you trying to consider. So after analyzing this particular question, we can simply go to our solution. So we can look for the ax, which is the x component. Remember, ax is just the x component of this particular vector. So if you look at ax from the lecture class we had, I'm sure you guys are able to watch, and that lecture has 3 parts. There is part 1 and part 2 and part 3. So from part 2 of our lecture, we said ax is simply equal to, so when you are looking for the x component of a vector, you're just going to say the resultant cos what? Cos theta. The resultant cos theta. So ax is simply equal to, so if you plug in what we have been given, remember we have been given 7.3, so we have 7.3 meters. So we're going to say 7.3 cos what? Cos theta, of which the theta here is just 250 degrees. So there are two different ways of solving the vectors. So the vector can be the angle can be in radian, and it can also be in degrees. So in our case, we need to make sure that our calculator is in degrees to avoid certain mistakes. Yeah. So you're going to say 7.3 cos 7.3 cos 250. What are you guys getting? 7.3 cos 250. What are you getting? I can't get you, yellow.
It's negative 2.49.
Okay, correct. So there it's just negative 2.4, negative 2.4967470046. So this is the solution, but we need to round it off. So in short, we are just going to say ax is simply equal to negative 2.50, because when you round off there, you are going to understand that this will be a 10 and then it will be a 5. So that's the x component. Then we can look for the y component. So for the y component, we are going to use the formula whereby we say ay is simply equal to a sin theta, of which theta is just the angle which has been given. So ay in this case, a is 7.3, and then sin 250, yeah, and then ay will be equal to, so if we plug that on our calculator, what are you guys finding that side?
Negative 6.859756132.
Okay, can I have the what, the rounded off, which is going to be negative 6.9, negative 6.9 meters. So one thing I need to explain concerning the answers which we have found are the signs. Okay, so if you look at this sign and that sign, these signs are just telling you the direction, and they are also helping you to know that, oh, what I've found is truly the correct answer by looking at the quadrant where we are. So the quadrant where we are, you need to understand that the x component has to be negative, and also the y component has to be negative. So this answer will simply confirm that what we did was right and correct. Do we have any questions, ladies and gentlemen? Do you have any questions? I'm waiting on you.
I have a question, sir.
Yes.
I wanted to ask, let me say, if the diagram, as in according to the question that we've been given, then the diagram is drawn wrongly, then the answers are correct. Then how can that be? Does it mean the answer is wrong from the diagram to the answers, or what? But in as much when you say the answers are correct, but the diagram is drawn in a wrong way.
Okay, that's a very important question. So the free body diagram, when marking physics, the free body diagram is very important because it gives the information about how you understand the question. And then the other thing that I can also say is that your answers can be correct, but when the free body diagram is wrong, you can't get the full mark. You get some marks, but not the full mark. Yeah. Is that okay?
Yeah, thank you.
Okay, so let's move and look at the next question. So the next question is, a ship sets out to sail to a point 120 kilometer due north. Okay, an expected storm blows the ship to a point 100 kilometer due east of its starting point. Then the first question is saying how far and in what direction must it now sail to reach its original destination. So if you look at this particular question, you just need to follow up what has been stated. You just need to understand what are they trying to talk about. Okay, so for you to understand such, you can use the help of the xy plane, and this xy plane is not really going to have the y component and the x component. Instead, it's something that's going to have the north, south, east and west. So instead of you saying the x component, y component, you're just going to say this is your north, and then this is your south, this is your east, this is your east, and then this is your what? This is your west. So you're going to use the compass for you to analyze this particular question. So from there, you can simply look at the first direction, which is 120 kilometer due north. So this is your origin, isn't it? So from here you're going to move like that. So northwards it has gone like that, which is the 120 kilometers. And then from this particular point it also had to go eastwards. It had to go eastwards. Okay, so from that particular point it moved east. Going east, that means that it had to go this side. Then the question is, how far from the starting point has this ship gone? Okay, this ship has moved. Okay, this ship has moved from this origin where it was. It went north, and north it went what? It went east. So how far from this particular point did this ship move? Okay, so if you look at this particular question, you can even write it in terms of the components of a vector, such that this will be your x component, this will be your x component, so this will be your x component, and this will be your what? Your y component. So you have the x component and your y component, and then this particular part which is connecting these two, it is your resultant. So your resultant in this case, it is this particular point. So this is what we are looking for. So when they say how far, they are simply looking for this distance, which is simply here. Okay, and then in what direction, they are simply looking about they are simply talking about the what? The theta, which we can easily find. Okay, so let's start with A. So we can simply start with A. They are telling us to find how far this guy went, and I remember, if this guy can be made to be the resultant, I remember from our lecture class I gave you the formula to use to find the resultant. Can someone tell me what is the formula of finding the resultant?
Resultant equals square root of x component plus y component squared.
All right, correct. So you're going to say x component squared plus the y component squared. So if you look at that, you're going to say r is equal to, the x component is simply 120, the y component is 120, and then the x component is 100. So since addition is commutative, so I can write it either ways. So plus, and then there I can just put 100 squared. So from there, r will simply be equal to square root. Someone who has quickly found, what are you finding when you put 120 squared plus 100 squared? What are you finding?
156.2.
I mean, what is inside there? 120 squared plus 100 squared. What are you having?
24,400. 24,400.
Okay, thank you. So inside there we're having 24,400, and then if you find the square root of the answer, what are you finding? When you plug in the square root, what are you having?
156.2.
156.2, and then that is in kilometers. Remember the unit. So the resultant, if you round it off according to the way they have rounded off there, this will just be 156 kilometers. So this is your final answer. Okay, I don't know if there is anyone with a question before we go to B. Any question? Any question? I can't get you. Yes, you can ask.
The answer she gave at first, it was already rounded off.
Yeah.
Yeah, so why did you put again 56 points? Okay,
You understand?
I understand because the question doesn't require for us to have it.
Yeah, yeah. Okay, we can move. So when you talk of direction, so direction, we said you just simply use tan theta is simply equal to the y components, the modulus of the y components, and then over x components, So that's what we said. So here we are going to have tan theta is simply equal to what are we having when you put there? What is our y component? Is it y component or x component over y component?
It is one y component over x component.
Okay, so what is our y component? It is 120, isn't it? Over 100. Okay, then when you plug in there, what is your theta? What is your theta?
It's 1.2.
Sorry?
1.2.
1.2. Are you sure? Anyone?
Yes, it's 1.2.
Okay, 1.2. 0.12. How come mine is different?
Sam, me I found 50.19.
Someone has found 50.19.
No, the final answer is 50.19, but we thought you're saying 120 divided by 100. But when you do the tan inverse, it's given 50.19, which is 50.3.
50.19, which is 50 point what?
0.3.
Okay, degrees. So that's the final.
Oh, sorry, 0.2. 0.2.
Okay, 0.2. All right, so this is just the final answer for that particular question. I don't know if there are any questions from you guys. Any questions? Any questions, Christians?
Then I have a question. I only want to ask how to calculate the tan inverse on the calculator. I'm not finding the 50.2. I don't know what I'm supposed to do.
Do shifts, press shift. Have you done that?
Yes.
And then you write shift 1.2.
Shift 1.2.
Is that okay?
No, not yet.
Okay.
Still, it's giving me 0.2.
It is shift done. You press shift first, then you press done, and you write the number.
Okay. Alright, thank you very much.
You're welcome. And say hi to your dog. Okay, we move. Solution. So the next question is, a person walks in the following pattern. A person walks in the following pattern. So these questions is just to follow them up how they are moving. So a person walks in the following pattern: 3.1 kilometer north, then 2.4 kilometers south, and finally 5.2 kilometer south. So the first question is, sketch the vector diagram that represent this motion. So we are going to use still the XY plane, so you can have that, and then from there you can simply put the directions. So you have the first one is the north, then you have the east, and then you have south, and then lastly you have west. So after knowing that, the next thing that you need to know is for you to understand the movement of this particular motion. So the first thing is 3.1 kilometer north, so meaning it's moving northwards 3.1 kilometer, which is like that. So this is the first movement. So this movement is 3.1 kilometer, like that. And then from there you can look at then 2.4 kilometers south or west, sorry. So it has gone this side now, and then this side it has simply gone what? It has simply used the 2.4. Then after that it is going south 5.2. So it has gone south 5.2. So this is how it has gone 5.2. So this is just a sketch which I'm making here, but this sketch is not accurate according to what we are supposed to know. Okay, so after you have this sketch, this is the sketch I'm writing, this is a sketch. Okay, so when you have this sketch in mind, now you can utilize this sketch in mind to come up with the what? To come up with the correct way of making this guy to be okay. So with that in mind, this is how you're going to come up with the diagram. So the proper diagram has to be a bit accurate as compared to the sketched one. So remember, we have the north, we have the east, we have the south, and we have the what? The west. So I'm going to draw a proper diagram which can help you to know what you're supposed to do. So the first thing is 3.1 north. So you're going to move the same way we moved at first. So this guy is 3.1. So 3.1 will be like that. Okay, so this is 3.1 kilometer. Then after you do that, you can sketch for 2.4. So you're going to move 2.4 like that. So remember, if this was a bit long, since this thing is small and then that one is big, so this one can be a bit short, which is 2.4 kilometers. Then the last one is the one which most of the examiner will focus on, because the last one has to be a bit longer than the first one, which is 5.2. So you're going to move a bit down there. So this will be your 5.2 kilometer. Okay, so if you look at this particular motion, some of you submitted this diagram. So if you submitted this diagram, you were totally wrong. This is just the gathering of information, but this is the accurate diagram which you are supposed to make sure that you draw. Taonga, kindly mute your mic. Okay, so this diagram, some of you sent me this diagram as your solution, which is wrong. You need to have this diagram, because this diagram is able to tell what you really expect out of this particular vector. So from there, after you sketch the vector, this vector you have sketched, So it's very easy for you now to come up with the resultant vector. It's very easy for you to come up with the resultant vector. So let me quickly get rid of this sketch or gathering of information. So you're going to use the same xy plane. You're going to use the same xy plane. So you have the y axis and then you have the x axis like that. But in this case, this is our north, this is our north, this is our east, so this is east, then there you have south, and then you have west. So from the information gathered, you can easily come up with the resultant. Okay, so if you look at this y axis, the sum of forces in the x and y axis, it is 2.4. So you can easily put a 2.4 there. So this 2.4 can come there because this size and that size are just the same, this size and that size. So this will be 2.4. And then after you sketch your 2.4 there, you can simply consider what? You can simply consider the difference between 3.1 and the 5.2. So 3.1, 5.2 minus 3.1. So your answer will be 2.1. But in this particular case, you need to know that this is the negative side. So from there to there, you need to expect 2.1. So this is just 2.1. So the resultant is on this particular part. So if you look at the resultant is for this particular part like that. Okay. So this diagram is showing the motion. This diagram is showing the what? The motion. Okay. This diagram is showing the motion. But this diagram is giving the summary of everything. Okay. So if you look at this question, the question is how far and in what direction would a bird fly in a straight line from the same starting point to the same final point? So this is where now you need to be a little bit careful and be able to apply what you have learned. Okay. So if you look at the first diagram, okay, the first diagram, you are okay to show the motion. This is the motion. This is the answer for A. But for you to answer the next question, which wants you to know the direction and the distance, like how far and also the direction, you need to have this information. You need to have this particular information. So from there now, I'll draw the diagram which I just drew recently. So I'm going to have that and that. So from there, you're going to understand that we are having the first guy, which is 2.4. So we have 2.4, and then we have the other one, which is 2.1. So in such a case, if you look at that, you can simply identify that this is the resultant vector we are looking for. So from if this resultant vector, let's say this resultant vector is A or R, whatever you want. So that means that, let me use R, which everyone is used to. Since they haven't specified, we can just use R for you guys to understand. So this is R. So this means that the Rx is what? 2.4. And then the Ry is 2.1. So from there now you are able to know the direction and also the magnitude. Yeah. So this can be negative, that one can be negative because this is the x, this is the third quadrant, but we want be interested in much of the signs. So to find how far, part, you're going to use the formula r is equal to rx squared plus c ry squared. So r is simply equal to the square root of 2.4 squared plus c 2.1 squared. So r is simply equal to, can someone tell me what is 2.4 squared plus 2.1 squared? What are you having? What are you guys having? 2.4 squared plus 2.1 squared?
10.17.
10.17. And then the square root of that?
3.189.
Okay, so 3.1 kilometer. So that's our final answer. Then the other one is direction. So the other one is direction. Okay, so if you look at the direction, you can simply use the formula which we have been using. So this formula is just simply tan theta is simply equal to the y component over the x component, over the x component, of which you can put the modulus. Yeah, so tan theta is simply equal to the y component is simply 2.1, the y component is 2.1, and the x component is 2.4. okay, the y component is 2.1 and the x component is 2.4. so if you plug in there, what are you having? Those with calculators, what are you having after you work out that? What are you having? What are you having?
It's 1.18.
So
26 point.
41.19, okay, degrees. So this 41.9 which we have found is for this particular angle here. So this particular angle, which can be any angle you can think of. So if we want this theta, we can change it to anything or whatever. So this angle here which we have found here, it is 41.1, but what we are looking for, it is something that is in the what, in the third quadrant. So we want something which is this particular angle, because what we have found is that angle. So we are looking for that thing which is there. So for us to look for this angle here, which we can call it alpha or anything if you want. So in my case, I want to use alpha. So in that case, I can just simply say alpha is equal to 180 plus theta. Yeah, 180 plus theta. So alpha is simply equal to 41.19 plus what? Plus 180. So what are you having when you plug in?
221.19.
Okay, correct. So the answer is just going to be what? 2.21 degrees. So 221 is our final answer. So if you want to represent your work in polar notation, remember we learned about polar notation. So you're just going to say 3.19 kilometers, 221 degrees, like that. So this is the polar notation. So this is the polar notation. Yes, any questions? I can see someone with a hand. I'll start with Frederick. What's your question, Frederick?
Sir, myself, I'm getting a different answer after writing tan inverse 2.1 divided by 2.4. I'm getting 26.89. And the final answer that I'm getting after adding that figure that I've just said to 180, I'm getting 206.89 degrees.
Okay. What is your x component? What is your x component?
My x component is 2.4.
2.4. And then what is your y component?
And my y component is 2.1.
Okay.
2.1.
Can you do 2.1 divided by 2.4?
2.1 divided by 2.4.
Yes, it's what?
I'm getting 26.89, sir.
So you're
Write
solving.
tan inverse first.
Can you get me? Do 2.1 divided by 2.4.
Yes, I can, sir.
2.1 divided by 2.4. What are you getting?
I've written it.
What are you getting?
Tan inverse 2.1 divided by 2.4, I'm getting 26.89. 26.89.
Listen to what I'm instructing you. Place on your calculator 2.1 divided by 2.4. What are you having?
I've pressed
Yes, put equal to what are you having?
0.875.
Okay, now place
0.875.
tan inverse answer. Tan inverse answer. What are you having?
Oh, I'm now getting 41.18.
Yeah, that's
So I did it wrongly. Myself, I used to press tan inverse, then the figure follows.
okay. That's the right way of doing it. Okay.
Thank you for that correction. I thought maybe
Benzo.
not using the same one.
Benzo, what's your question?
My question, but I want to raise it for me. So since you said okay, it's about the rounding off. I'm a bit behind because the x and y components are rounded off to 1 decimal. Then the resultant here, it was rounded off to 2 decimal places. The first theta was rounded off to 2, and then the alpha, the last one, we didn't round it off. So how does the rounding off work? Like, I'm a bit confused. I don't know.
Okay, so basically in physics they don't really follow much about the rounding off, but the only one concerning this one, maybe the only one you can round off to 2 decimal places, it is the 3.2 kilometer, the one for the resultant. Yeah, that one you can round off to that, but for the angle you're not supposed to round it off. It's just supposed to be like this.
Okay, thank you.
You're welcome. Taonga, what's the question?
My question was this one, we did 1/8 plus alpha. So can we do 270 minus alpha to find the final theta?
Okay, I would advise you to say 180 plus theta, because for the third quadrant that's the rule. Third quadrant, that's the rule.
Okay.
Yeah. So if this guy here 41.19, it is for that guy we found there, and then for you to find this other angle, it is not really 41.19. that other angle is different. The other way I can explain it is this guy. Let's say we extend this guy this side. So this angle we have found is for the first quadrant. So this angle we have found 41.19, it is for the third quadrant. So for the first quadrant, then this angle and that particular angle are the same, they are equal size. That's why we just wrote direct like that. Okay, let's move on and look at the next question. So we have this particular question. I have a question from Florence. Yes, Florence, what's your question? Florence, what's your question? Okay.
I wanted to ask that, so in short, there, let me say, just for the straight line, it's 180. This is why we have used 180. Then for the theta, it's 41.19.
Exactly. So if you have the XY plane like that, you know that the angle from here to there, it is 180. It is 180 degrees, but we are now having an added angle, which is this one, which is 41.19. Yeah. And then who is this? Benzo. You have made me remember something. When solving anything in physics and chemistry, do not round off much. Like, don't round off from this point, okay? And also don't round off, let's say, from that point. At least try to have maybe 2 decimal points, 3 decimal points, like that. That is helpful and will help you not to have some issues with decimal places or answers. Okay, we move. The next question is, a displacement vector r in the xy plane is 15 meters along and directed at an angle of 30 as shown in the figure below. Determine 1 the x component and 2 the y component of this vector. So this is very easy, and this is something that we have already done. So if you look at the size of this particular vector, it is 15. It is 15 meters, and then the angle there is simply 30 degrees. So this is the basic, very basic solution. And for those who don't have information on this, you can just simply watch part 2 of our lessons. So from there you can simply work out that. So we know ax, since we have the vector is what? The vector is r. We are not going to use a, we're going to use r as our reference point. So the x component, you're going to say rx is equal to r cos theta, and then rx will simply be equal to, you're going to put 15 meters cos 30. So what are you finding when you plug in 15 cos 30? What are you having?
12.99.
12.99. Okay, 12.99 meters, and this can be rounded off. When you round it off, it's just going to be 13 meters. So this is the x component of this particular vector. Remember, this vector is having the x component, which is this side. So this is the rx. Then we can look for ry. We can look for ry, which will be our b. So ry will simply be equal to r sin theta, r sin theta. So ry is simply equal to 15 sin 30. Okay, it's 15 sin 30. What are you having when you plug in that?
7.5.
7.5 meters. So our ry is just simply 7.5 meters. So when you talk of the r component of this particular vector, let me just quickly show you. So the r component, the ry is just this part here. So this is the ry, or the y component, and the other one is the x component. Then you need to be careful the quadrant. So this is the first quadrant, so this is the first quadrant. So since it's the first quadrant, we need to expect both components to be what? To be positive. So this is the correct answer for this particular question. Okay, do we have people with questions on this one before we go on the last question? And then next time we meet for physics, probably tomorrow, probably tomorrow, then I'm going to teach the other remaining questions from the same tutorial sheet. That means that by the time we are reaching Saturday, we are also going to handle the other tutorial sheet, and next week we'll be doing projectile motion. Okay, so let's move on and look at the last question. So the last question is also simple. So the last question is the x component of a vector A is negative 25.0 meters and the y component is positive 40.0 meters. What is the magnitude of A? What is the angle between the direction of A and the positive direction of B? Okay, so this is a very easy question you need to understand. So we can say this is the xy plane and this is the y component and this is the x component. Y component, x component. So with that in mind, you can just correct the information which is there. So this vector is negative 25 in the x component. So the x component is negative 25. So this is the x component. Okay, so the y component is 40, so it's going up. Remember, you need to move from the 8, so that means that we are going to move from there and then we go up like that. After that, we can sketch the resultant. We can simply sketch the resultant. So the resultant is simply that particular part. So this is the resultant A, and then you know the ax is simply equal to negative 25.0 meters. So that's the ax there. Then the ay, which is the y component, is simply 40 meters. So you have 40 meters there. So with this information, we can simply look at the magnitude of A. You use the same formula and then you just say, you know, it is ax squared plus ay squared. After that, you can simply say A is equal to, so remember always to write the formula. That is very important, and sometimes it might carry some marks depending on who is marking you. So that squared plus, and then there you have 40 squared. From there you can say A is simply equal to square root, what are you having, 25 squared plus 40 squared. What are you having? 25 squared plus 40 squared. What are you getting?
975.
975. And then if you do the square root of 975, what are you having?
31.2249.
30?
31.
Yeah.
0.22.
Okay.
49.
Just a moment.
Yes. What's your question?
Yes, negative 25 squared plus 40 squared is giving 2,225.
Are you sure?
Yes.
2000.
Yes, he is right. I'm getting the same.
Okay, then
2225, sir.
okay, let me write it.
And the final answer is 47.16.
What's negative 25 squared plus 40 squared? 2 what? 2000?
2225.
220.
And then what are you having the final?
47.169.
Okay.
47.16.
Okay, so 47.16 16 9 okay meters, so this can just be written as 47.1 meter. Yeah, you can write it in such a way. Then B, let's quickly look at
Sir,
B.
not
2. Oh yeah,
Sorry, sir.
thank you. 2, that's good.
Now, how come am I finding the same 975?
Maybe your okay, so your mistake is on you are writing negative 25 squared, you're not putting brackets. So the easiest way you can do, since it's a negative,
Yes, I didn't put.
yeah, since it's a negative, you just say 25 squared since it's a squared. So yeah, so that's why you're making a mistake. Are we now?
I should add brackets, sir?
Yeah, put brackets squared, then you say plus C 40 squared. What are you having? Are you having what we are having?
Alright, yes, I'm now having the 225. The 225, yes.
Okay, so the next one is you're going to use tan theta is equal to modulus of the y component over the x component. Then you can say tan theta is simply equal to the modulus that can be 40 over 25. So theta is equal to, what is it giving you there?
57.99.
So 57.99. So 57.99. 998. Okay, so after you do that, this 57.9998, it is for this angle here. So 57.998 is for that angle there, but the angle we are looking for, it has to start from this particular point going like that. So this is the angle and we can treat it as alpha like that. So in such a case, we just say alpha is equal to, you're going to say what? How are you going to find this? By the way, no, not that which I've drawn there. It's wrong. Okay.
And there's not 57.998, but it's 57.995.
Okay, all right. It's okay, given that. So the angle we are looking for, it is, let me just draw it. The angle we are looking for, it is this angle. Okay, so the angle we have found, it is this one, but the angle we are looking for, it's that particular angle, the one I'm shading in blue. So please take note of that. And then we have this other angle, which is 180 degrees, the one which is 180 degrees, but we are not using the 180 degrees. So in such a case, you're just going to say 180 minus 57.995. What are you having as your final answer? What are you having?
122.005. 122.005 degrees.
0.005.
22.
Okay, degrees. So this is our final answer. So if you want, you can present it in a polar notation, whereby you say 47.2 meters, 122 degrees. So this is your final answer for this question. Do you have any question so far? Any question? Any question? Okay, since we don't have any question, I think we'll end here for physics. So we'll end here for physics, and I'm going to share this recorded video to you guys. The chemistry video is on our YouTube channel. I hope you guys have checked it up, and make sure that you are not lagging behind. So make sure that you are following up all the classes. I know some of you are working, but just learn to balance up. During the day you're working, and then at night you go through some few questions. So for now, thank you very much for the physics class.